Hi everyone! This series of videos is going to kick off the new chapter, which is Unit 8 on exponents and exponentials. This actually begins the last stretch of new material that we're going to learn this year, which really focuses in on that family of exponential functions to help us understand what we can do with exponents. And as we combine what we know from Algebra 1 with what we just finished learning about geometric sequences, you'll start to actually see a lot of interconnectedness. So the main purpose of this chapter really is to help you kind of bridge the gap from what you just learned with sequences to the bigger picture of mathematics. This chapter is actually great also to show you a lot of real life applications, things that you'll actually see and hear about in your real normal daily life. And I know sometimes math teachers say that and we kind of roll our eyes and say, oh, that's a stretch, Herbert. Really, I'm not going to solve equations in the grocery store. But especially in our current climate where we're talking about things like exponential growth, the whole coronavirus thing, for example, is predicated on exponential growth. This chapter actually covers exponential growth. So some of the things you may be seeing and hearing and reading about, if you're following the news, is actually modeled on this exact type of mathematics. So it's super topical, but it doesn't just have disease-related implications. It has implications to things like banking, loans, things that you would do with credit cards. Many of the things that you hear, even in commercials, about things like percent interest rates when you buy a car or buy a house, those are exponential as well. So as kind of an intro, I do want you to appreciate the fact that this unit really does attempt to give you some real life useful information that you can adapt and hopefully in some way use when you're actually outside of a math classroom and going about your normal business with lots of different implications. In any case, make sure before we start this unit that you do have access to the new problems. They're posted in the learning plan as a PDF. The entire PDF is posted in the learning plan, so if you have a printer, you may want to consider printing the entire new packet so that you have access to each of the pages, and then you can simply staple it together like you see I did here, poorly. Or you can go day by day and just print the pages that you need. If you don't have a printer at all, you can simply have the PDF open, maybe in another tab or on a different device, and you can just do the problems in a notebook or on a piece of paper as you follow along with these videos. Just as we've done with other chapters, the videos are not required, but this is meant to emulate the in-class lectures, the in-class instruction, the in-class notes that we normally do. So if you feel like you've been missing that in-class component and struggling with just doing the quick checks or doing the big ideas homework without having any instruction involved, these videos should help you kind of bridge that gap. My goal, even though it's not super interactive, is to mimic the conversations I would be having with you if I was still standing in front of the classroom and you were still in the classroom. We're obviously not going to be able to dialogue back and forth, and really by me and you, I mean like me and 3 people because we're all asleep in the mornings. But nevertheless, this hopefully will at least emulate my part of things. So if you need to hear me explain and see my work, hopefully that'll give you something that you can apply to the quick checks and to the homework when you do those problems on your own. Now, all that to say is that that's a big introduction into what we will really try to accomplish today, which is the first lesson, and it's just on exponent review. I say the word review loosely here, not because we've done a whole lot with exponents in our class specifically, but in Algebra 1 you probably learned some stuff about exponents. So this section is attempting to bridge the gap between what you learned in Algebra 1 regarding exponents and what you just learned in the previous chapter regarding sequences. Because while those two things may not have seemed related, there's actually a lot of overlap, and that's what I want to make sure that we go into here, because I think it'll help give you a conceptual understanding of why exponents work the way they do. This first video is going to go over question number 1, which is about a function f of x. Now, we don't use a whole lot of function notation in our class. Maybe in your Algebra 1 class they did, but the deal with function notation is actually pretty straightforward. F of x is just the name of a function. So this function is named f. But the actual function or the equation is the part on the right-hand side, 8 times 1/4 to the power of x. Now, if that structure looks familiar to you and it looks like a geometric sequence to you, that's good, because that's actually what we're going to be focusing on, is the fact that this looks very much like a geometric with an initial value of 8 and a multiplier of 1/4. We know it's geometric because of that power of x. And usually, while with sequences it was a power of n, the idea was that it was the power, the exponent, that sort of tipped us off, like, oh yeah, 1/4, that must be the multiplier, because that's always the number inside the parentheses with the exponent outside. So it's those little context clues that we want to make sure we pick up on. In any case, if we were just doing this like an algebra problem, then in letter A, where it says if x equals 0, what is f of x, we would just basically do a substitution. F of x becomes f of 0. By substitution, it says x equals 0. So we would just replace the 0 into the parentheses of the function where it says x. And then after the equal sign on the right-hand side, we would say 8 parentheses 1/4. And instead of x, we would plug in 0 as the exponent. Now, the reason why I'm not actually going to ask you to do this way is because we've never really talked about what this means. Like, what is 1/4 to the 0? Maybe you know some stuff from Algebra 1. Maybe you know some rules of exponents that allow you to do this, or the order of operations will help you. That's cool. But I'm actually not going to focus on this right now. So even though it might seem weird, like, wait, Herbert, you're crossing out how to do the problem. What are you doing? I'd rather focus on this as a sequence, because that's something we have talked about in class, well, at least in online class, and that's something that hopefully you can make a connection with. Remember, as I mentioned, this should remind us of a sequence. Instead of n and t of n, we have x and f of x as our letters, but that's okay, it's still a sequence. We know that the initial value of the sequence is always the number that's out here in the front, the number that's before the parentheses, the number that's not attached to the exponent. So in this case, the initial value, or the 0 term, would have been the 8. And that the next term would be generated by multiplying 1/4. We know that the 1/4 is what we call the multiplier. So if I multiply by 1/4, the first term, which would be the next term in the sequence, would be 8 times 1/4, or 8 divided by 4, if you want to think of it that way. And that would be 2. Because again, you can think of it as dividing by 4 or multiplying by 1/4, whatever suits you, and that would give us the next term. And that if we divide by 4 again, or again multiply by 1/4, whatever you want to, 2 divided by 4 would be 2/4, or 1/2. Now that we're in fractions, it might actually be more helpful to think about this as multiplying 1/4. Because again, all of these are technically multiplying 1/4 anyway. So 1/2 times 1/4 would be 1/8. You could also think of that as 1/2 divided by 4. If you kept the sequence going and either multiplied by 1/4 or divided by 4 again, whichever way suits you, you would get 1/32. And then the pattern can go as far as you want to. That's the beauty of sequences, is we know that we can extend this pattern infinitely, however we want, now that we know the multiplier and now that we know how the pattern grows. So in any case, if we go back and look at number 1, letter A, in context, it says if x equals 0, what is f of x? Well, I'm just going to look at my table, and I'm going to notice pretty obviously that if x is 0, f of x, the initial value, is 8. So I don't actually have to like do any math per se. I actually didn't have to do any fancy work like I talked about in the beginning of the video. I could, I just don't have to. If I have a table, this is basically saying, hey, go to the 0 term in the table, tell me what's there. Letter B is saying, hey, go to the second term in the table, tell me what's there. Letter C is saying, hey, what if you went backwards in the table? If you went backwards to the negative third term, what would be there? So challenge yourself for a second and see if in a table type format you can answer question number 1 and do all of the parts. I'm going to emphasize this table format just so that you can keep it linked to sequences. But if you want to try to do these questions with other rules of algebra that maybe you understand better, that's fine too. Just have the answer key open, maybe in a separate tab or a separate window, so that you can check to make sure that whichever way you're doing these problems, it makes sense. In the next video, we'll talk about question number 2, which is again just meant to kind of help us link this idea that we're going to see an expression, but really the expression just represents sequence values that we can understand, an initial value and a multiplier that we can generate for as many terms as we need.